choose Singapore because of our trusted environment and because of our welcoming culture of diversity and growth. I'm encouraged that Atomionics has brought together in Singapore a stellar team of scientists, engineers, and AI specialists from around the world. As more innovation activities are anchored here, they create opportunities for collaboration, capability building, and I hope in time to come, knowledge transfer so that in Singapore we can have more spin-offs and more partners and organizations benefiting from what you are developing right here. The opening of this facility reflects what can be achieved in research excellence, entrepreneurial ambition, and public-private partnerships work together. It's like connecting the dots. Sometimes it takes a while for us to find the dots, and sometimes it takes a while for us to link the dots together. But I'm glad that Atomionics has succeeded thus far in finding the dots and getting them connected. And the government will continue investing in the capabilities, infrastructure, and the people so that we can grow Singapore's deep tech ecosystem. Our goal is to enable more companies like Atomionics to develop and scale frontier technologies from Singapore to the world. I look forward to seeing continued push of the frontiers of technology and also to translate innovation for impact in the world. Once again, congratulations to the team from Atomionics and all the partners who are here today. Thank you.
Thank you for those incredible words of support, and it has been an, as you said, it has been sometimes connecting the dots takes some time, but we are now on that trajectory, and there are future dots that we also see, and those will be formulated over here. I just also wanted to continue on some of our announcements with something strange. I want to begin with something strange right now. More of the surface of Mars has been mapped in high resolution than the floor of our own oceans. We have better pictures of a planet that is 200 million kilometers away than of a seabed a few kilometers off the coast. And this is not for the lack of trying, for a lack of way to see. For all of human history, the world beneath us, the rock under our feet, the ground beneath the sea, have been the last dark place on Earth. We have walked over it, sailed over it, built our entire civilization on top of it. But we have never been able to see into it. And that is the problem we started Atomionics to solve. We built quantum sensors to see what nothing else can. And our instrument reads the faint pull of gravity from every mass hidden beneath the Earth's surface. And our AI turns that pull into a living three-dimensional picture of what lies underneath. We simply see. But our ambition is larger than building a better instrument. It is to map the planet, not merely its surface, but the world beneath it. We began with mineral exploration because the global economy depends on materials that remain extraordinarily difficult to find. Copper, lithium, and other critical minerals power our grids, data centers, and advanced technologies. Yet exploration remains slow, expensive, and dependent on extensive drilling. By combining quantum gravity measurements with geophysics and AI, we can give explorers a clearer three-dimensional picture before they drill, helping them make faster and better decisions. With every deployment, we add to a progressively richer model of the planet's subsurface. But if our ambition is to map the planet, we cannot stop at the shoreline. So this morning, we do something that has never been done before. We turn it towards the sea. Atomionics will be developing the capability to secure the seas with the development of a marine intelligence capability. With close collaboration and support from the Ministry of Defense, CAPVISTA, and Enterprise Singapore, Singapore will lead the way in our understanding of our oceans. Consider what that means for finally seeing beneath the sea. It means knowing the seabed our ports and our shipping depend on, not from charts drawn decades ago, but as it truly is, and the way it changes. It means the undersea cables and pipelines that carry the nation's data and energy can be watched over and protected. And for an island nation like ours, this capability secures our coastlines. Singapore lives on the water. The busiest shipping lanes on Earth run past our shores. The cables that carry the region's voice to the world come ashore beneath our waves. Everything we are rests on a domain we have never truly been able to see until now. This capability is how we begin to see it, to map our own waters, precisely, quietly, on our own terms. Not a capability that we rent from somewhere else, but one built over here. And no one builds something like this alone. To our partners at FSTD, we thank you for the ambition to build this capability here and to build it with us. To CAPVISTA, thank you for recognizing what this technology means for Singapore and moving to secure it. And to Enterprise Singapore, thank you for making this country a place where frontier technology is built and not just imagined. In a few minutes, we're going to take you inside. You will stand in front of a quantum sensor and watch it measure gravity, live in real time. You will see a cloud of cold atoms, cool to absolute zero. It's literally the coolest thing in the universe. Drop in free fall and read the pull of the entire planet beneath the atoms. You will see the machines that have already crossed the world and ones being built right now for what comes next. And I want you to hold one thought while you do. Everything you're about to see was once impossible. That you could weigh the earth by dropping atoms. That you could look through solid rock and deep water without touching either. That a company born here in Singapore could build it and carry it to the world. The complete map of the world beneath us has never existed, not once in all of history, but we are going to build it. And it begins here, in this room with all of you to witness it. Thank you for being here at the start of it.
Thank you very much, Honorable Minister, for being here and inaugurating this facility, and for your best wishes, and all the other distinguished guests for the presence as well. Now we are going to go to the labs. I would just want to tell you, what are we going to actually see? This is something we are going to witness, how we build quantum sensors. And these are the sensors which are going to revolutionize another century from here onwards. So, however, this is not the first time that actually quantum revolution is happening. We are actually sitting here at quantum 2.0. However, quantum 1.0 also happened before, in a way that when we understood atomic structures, when we understood band gap materials which give rise to semiconductor industry, all of these electronics that we see, our phones, computers, internet, all of those things are fundamentally built from our understanding of quantum technologies right from the beginning as a quantum 1.0. But now, from here onwards, we are entering into a generation where we will see quantum 2.0 revolution. And this is the very first glimpse of that. Now what comes after, yes, we spoke about several use cases. However, at this point, I would say it won't be possible to even imagine the kind of use cases these quantum sensors can actually be applied to, and how would they change the world across us. However, now, what we are saying quantum 2.0, the way it is different, and now we start talking about like superpositions, we start talking about entanglements, we start talking about matter-wave particle duality. Fundamentally, these instruments are using those properties, wave particle duality, to build these instruments, and based on that, we can do very high sensitivity measurements. Today, we'll go to the labs. We have like 3 different labs over here. First one, we build electronics facilities. We'll go and see some of those parts and pieces of what goes inside the instrument. Then in another room, we'll go and see live how do we get cold atoms, and then how do we play with that. At least some of those things, what could be environmental sensitivity, how they can capture, we'll see some of those glimpses. And then we'll move to another room where we will demonstrate live, like how do we do these gravity measurements that just Sahil was talking about, that we have deployed it all across the globe. So these are actually the instruments which goes around the world and collects the data, and then we have been able to demonstrate some of these. So thank you so much for your presence as well, all of you, and let's go to the labs and see some of these machines. Thank you so much.